My name's John Clayton. I'm the technical director here of Micron Sprayers. So the company was founded really by an inventor, a man called Edward Balls, and who wanted to improve crop protection basically around the world. We've been established since 1954, and we are basically specialising in sort of spray application technologies. Our specialisation really is in the creation of Micron very accurate drop sizing and delivery of sprays, exporting around the world over probably regularly to over 60-70 countries every year. Something like 2 million farmers in Africa use our technology because it cuts down on water requirement. The company probably in the early days were using cast metal parts and various other things, and then when the plastics came in the late 70s, injection moulding, a lot of our products are designed through injection mould. Since then, obviously with the advent of computer-aided design, that has transformed our business. We can produce 3D models now, and the next logical step really was 3D printing.
We looked at FDM, and then we went down the 3D printer route for Raise 3D and N2 machine. Then we started looking early this year into other techniques, and that is when we went into the Photocentric Magna machine.
Yeah, so for me, from a testing and development side of things, it's really useful to be able to get prototypes out there quickly and change them and test how certain parameters affect your results. Especially with our droplet sizing laser, we can trial different disc types, different sprayers, and see what those changes make. And I think that's going to be key to a lot of the stuff that we do in the coming years. It's exciting not having to tool up or do difficult manufacturing processes, to just try iterative little steps, really.
The way that Micron have gone about actually adopting the Magna and the floor has made this actual visit so easy for me, because they've embraced the technology completely. Having come from FDM now onto the photocentric type of technology, they're now able to prototype parts very quickly. If they have a potential issue with the print, they're able to analyse the supports and the way that they set it up, and then very quickly reiterate and reset it going again.
We've only been using it 3 months. As we say, we have started doing R&D techniques with it. We've now gone into production items with it. It's quick and easy, and we can produce more technical products.
The FDM, whilst good for prototypes, just wasn't really capable of doing production runs, and really the Magna I think is going to help with that for small scale items which are very specialised for custom applications almost. I think it'll be really useful for that.
You fill a vat with resin, you can then leave it and the build plate comes down and you just leave it to go and it does its thing. There are other processes involved. You have to start cleaning the parts or the build plate a little bit more. So you take it from the unit into a wash tank, which we have over here. So we use hot soapy water to start with. We then put it into the wash tub. We then take it out, we wash it again, and then we put it into the cure unit. The material can come away easy, as in the support structure, where sometimes on the FDM, if you get it wrong, it can snap, the build's not quite right. But so the overall process from the photocentric is totally different, a lot quicker, and for us, a lot more easier to use. The transition going from an FDM to the resin-based unit, we have found overall a very easy, smooth process.
So they're now at a stage where they've got confidence with how they're oriented in the parts and how they can print the parts. The next step now is to look and revisit the whole workflow to be able to get the parts to a finish that they feel is good enough to go out there to market. to be able to sell them as end-use parts. So looking at how better to post-process the parts, clean the parts, wash the parts, and then potentially polish the parts. So they've got that end-user finish that you would want from a consumer part.
What is getting very interesting now is the transition, because we're obviously using, we have CNC manufacturing operations for machine metal parts at the moment. But also we're seeing a transition really from 3D printing, moving from just being a prototyping tool for us to suddenly becoming something for low volume production, particularly with the technologies that we're using today. So that's really the progression, and I think we're only just at the beginning of this development.